Hi all, welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on decision support system that comes under the unit application of RS and GIS under the subject Geographical Information System for the students of third year Agricultural Engineering 5th semester. So before going into the session, let us have a small recap what we have seen in the previous classes. We have seen about crop acreage estimation, how we can predict the crop condition, how we can map the soil erosion data, how we can identify water resources inventory, and recently we have seen about precision agriculture. Today's topic are what is support system, how we can identify the decision challenges, the role of GIS and GPS, and application of GIS and GPS in decision support system in agriculture. So the decision support system usually provides a framework for integrating database management system, analytical models, and graphics in order to improve decision making process. So the decision support system concept was extended to the spatial context by integrating GIS into spatial decision support system. Because of lack of computer software to develop a user-friendly interfaces in the past, GIS have not been used as a part of decision support system, so that instead we have been using to generate and store the spatial data which were then used as inputs for the analytical models. That means that usually it is an interactive computer based system, usually helps the decision makers to utilize the data and models to solve the unstructured problems. The concept was significantly extended by integrating the GIS and the decision systems. Why do we need spatial decision support system? As we all know that the increased food demands due to the high rate of population growth and major changes in political and economic and social systems have created an urgent need to develop new and revise many existing agricultural systems and practices. And India has already characterized with high population with a larger growth rate and also the restless onslaught of the demographic pressure, additional people on India's natural resources and high production gains limited to endowed irrigation areas. So this is where the decision support system came into existence, because we have to integrate both the spatial decision support system and the GIS, so that we can use GIS as core tool, and along with the components and visualization, the insights that we have received from these could be used under technology convergence and then convert them into a decision making. So as you all know that site specific management, precision agriculture is usually dealt with the help of site specific progress, because the site specific nutrient management will help us to feed the crop in need, and then it will provide us a very good crop. So that is why the precision farming systems utilize a combination of technologies including GIS, GPS receivers, continuous yield sensors and remote sensing, geostatistics and variable rate applicators. It usually aims to optimize the farm returns and minimize the chemical inputs and environmental hazards by directing the application of seed, fertilizer, pesticides and water based on specific locations within the fields. So the core components that are involved in specific data decision system is the first thing is spatial data management, and then interactive maps and dashboards, analytical and simulation models, and the final stage is going to be the decision rules repositories. Why we are claiming them as the core components means because this will help us to regulate the national and regional policy decisions. We can come across a number of papers in scientific literatures on the application of time series analysis to the data collected by the State Directorate of Economics on the statistical organizations. For example, Here I'd like to quote an example, that is, on the studies on agricultural growth and assessing the dynamics of cropping pattern, land use and livestock population, we have come to an existence that the data are available at district level, but the performed on the aggregate data at national or regional or state level depending on the study. But the analysis of aggregate data does not infer about location specific trends and spatial patterns, which are very essential for agricultural policy, planning and management. So that is why we have come to a policy analysis and decision making with consideration of these kinds of core components, so that we can identify a place where specific regional location could be identified and worked into it. So with summarizing this, what we have seen as of now is how we can use GIS in decision support system in agriculture, and then how we can use this decision support system by integrating GIS, spatial decision support system in agriculture, and challenges and future directions. We have also seen an example of how we can locally identify the agricultural policies, and by converting them with the help of agro-eco regions, we have to statistically estimate the trends using the software and then integrate the current integration by considering the past usage limitations. So this is what we have seen for today's class, and the assessment quiz for today's session is: why is the analysis of district level time series data with GIS considered superior to analyzing aggregated national data for agricultural policy making? The first option is eliminates need for standard statistical software. B is requires less data and computing power, but C is reveals location specific trends, because precision agriculture is most probably in keen note of revealing the location with the specific trend. So the answer is going to be option C. So these are the references that we have used for crop health monitoring, and see you at the next class. This is what I have prepared for today's class. Thank you.